All right, so we started with arc length yesterday. I believe we got through examples 1 and 2, right? Okay. So examples 3 and 4, we're going to do the same kind of thing, but instead of finding the arc length, I'm going to actually have you find the radius. So we're just going to be given different information. So for number 3, the arc length is going to be, let's see, 4 centimeters. Actually, sorry, I did not want you to find the radius. I want you to find the angle. So we've got an arc length of 4 centimeters and a radius of 10 centimeters. Okay. So typically, when I've got anything like this, again, I would start with the formula that relates the two. So our formula for arc length is S equals R theta. And if the thing that I'm trying to find is not what's in front, so this formula basically gives us arc length, but I'm trying to find theta, I recommend rearranging the formula first, okay? So before I try to plug any numbers into it, now you can do it after you plug numbers in, but for things we're going to talk about later, it's typically easier to rearrange this before you plug numbers in. Because if you get things like fractions, then you have to deal with multiplying by a reciprocal or square roots. Just a lot of times it's easier to do this first. So if I'm trying to find the angle, how do I solve this for theta? Divide both sides by r. Okay, so then I just plug in what I'm given. So 4 divided by 10, that is going to be 0.4.
You don't want us to leave it as a fraction?
No, we'll put it as a decimal since this is, since it doesn't have pi in it, it's just a nice decimal. But what is our label here?
Centimeters?
It is actually radians. This formula,
That's disgusting.
this whole formula that we're using, remember the theta had to be in radians.
I was gonna say, when did it change to degrees?
So you, no matter what, change it to radians.
Well, we didn't change anything.
Well,
It's been
We didn't convert it to radians. It's just our answer for theta is in radians.
Oh, so we don't, like, when it says find the angle, we don't have to change it.
so
to
it's still
degrees?
0.4 centimeters.
So it still equals
No, it's 0.4
It's
radians.
0.4 radians, it never was centimeters.
It was centimeters at the beginning. You better pause that video.
The next part, we're going to transition here to talking about the area of a sector. So we're moving on from arc length. Okay. And again, a sector is just like a fraction of the area of a circle. So you can think about, typically it's a shape kind of like a piece of pizza, but it can be bigger than that. So it's typically made of an angle, and then it's going to be this shaded region, something like that. It could be varying angles. So it could be a tiny little sliver like that. It could, think about it kind of like a pie chart, okay, and the area of that piece.
So you would find the shaded part?
Yeah, that's what, when we're talking about the area of a sector, the sector is going to be that sort of fraction. Now it could be bigger or smaller. You could have a sector that looked like that. You could have a sector that larger part of the circle. Either way, just varying angles for a sector. We're going to derive the area, or we're going to derive the formula for the area of a sector. So I'm going to show you like how we get there, but if it gets too confusing, you guys aren't going to have to derive the formula on your own. I'm just showing you where it comes from, but then we just have to be able to use it, okay? The way that we sort of get this formula is by setting up a proportion. So, if I'm looking at the area of a sector, does it make sense that the area of a sector, since it's a fraction of the overall area of a circle, that ratio would be equal to the arc length divided by the circumference of the whole circle.
That's a lot of words.
So what I want to kind of point out here, for the area of the sector, again, you have a specific angle there, right, that's going to affect the size of the sector. Same thing for arc length. The arc length is going to be for that same angle. Okay, so that's why it's proportional, right? It's using the same angle, same portion of a circle. Does that make sense? So now, this is what we're trying to find, right? This is kind of the unknown. Now we're trying to find what the formula for the area of a sector is. All of these should be knowns, or at least known relationships to us, okay? So area of a circle, we should know how that works. Arc length we know, circumference we know. So can anybody tell me what the formula for the area of a circle is?
Wasn't it A equals pi diameter or
That's for circumference.
that's circumference?
Yeah, it's pi diameter, pi radius to the second power.
So area of a circle is actually pi r squared.
Oh my gosh.
Okay. So for area of a circle, or area of a sector, sorry, I'm just going to put an A there because that's going to be like the variable that I'm trying to solve for. Area of a circle is equal to
Pi r squared.
pi r squared. So I'm going to put all the variables in place for these things. So I'm replacing the area of a circle with pi r squared. Arc length is equal to what? We just did that. R times theta. So I'll replace that with that. And then circumference is,
Diameter times pi. Or
it's
radius.
diameter times pi, but since I'm using r for everything, I want it in terms of r. 2 pi r. Okay? Now, a lot of times people get those two formulas confused, so I want to talk real quick about that. So for the area of a circle, it's pi r squared, and for circumference, it's 2 pi r. A real easy way to keep these formulas straight, your radius is always going to be a length, right? Your radius is always going to be measured in inches, centimeters, meters, feet, something like that. So area is always units squared, right? Inches squared, feet squared. So it makes sense your radius is going to get squared to find area. Circumference is a measure of length. It's the distance all the way around your circle. Again, radius is a measure of length. So your units make sense with each formula. It doesn't make sense to square the radius for circumference because your units would be completely wrong. Does that make a little bit of sense? All right, let's continue here. This is basically all the setup that we need. I'm just trying to solve for A, which is going to be the area of a sector. So if I want to get A by itself, multiply both sides by pi r squared. So that'll cancel out. And then to multiply, we'll just multiply straight across. So when I multiply, I add the exponents on the r's together. So this is going to be pi r cubed theta divided by 2 pi r. And then, fortunately, I can simplify a couple things there.
R and pi.
Yep, notice I can cancel a pi out of the numerator and denominator, and I can also cancel an r out or subtract the exponents, and we should get that. And that is completely simplified. So that is our formula for the area of a sector. Now, there is another way of writing that. So this is just r squared theta divided by 2. The way that you'll see it written a lot of times is that it's 1/2 times r squared theta. Either one, those two formulas are equivalent. Dividing something by 2 is the exact same as multiplying by 1/2.
So that's the actual formula we'll be using to find the area of a sector.
Either one of those two.
Okay.
They're equivalent. Okay.
Which one do you use?
I personally like this one better because I just think it's cleaner to divide by 2 as opposed to multiplying by 1/2. But I'll actually say this is the one that you'll see more often, like on reference sheets or like in the book. I'll say this is how the formula is presented more commonly. So, but I honestly don't care. They're equivalent. It doesn't matter which one you use. Okay, they'll give you the exact same answer. Okay, it's like 10 divided by 2 is 5. 10 times 1/2 is 5. Doesn't matter which way you get there. Okay. Okay, so now we're just going to go through some examples using that. Okay, so the directions are going to be to find the area of the sector, and it'll also say, like on the worksheet or on a test, it'll say given the angle measure and radius, but I'm not going to, that's just going to be the information that it gives you. I'm not going to write all that down. And you said this was example 4, right?
Mm-hmm.
Okay.
Wait, so theta's gonna be in degrees?
Oh. No. So that is something I need to back up a second. So our formula was area equals r squared theta divided by 2. Theta is still in radians. And then your units here for the radius, again, because if your radius is in inches, then the area
It's gonna be in inches.
inches squared.
Oh,
Okay, if your radius was in feet, then your
Feet squared.
area would be in feet squared or square feet. Okay, so your units will still match, just the area will be squared.
36 times 54 divided by 2.
All right, so back to example 4. It gives you the theta in degrees. We need it in radians to plug into our formula. So you cannot just start plugging stuff in kind of willy-nilly. You're going to have to convert. So how do I convert 54 degrees to radians?
Pi over 180.
Pi over 180, multiply straight across, 54 pi over 180. Now, before we move on, and go any further, if I'm looking for the area, let's say I'm wanting to pour a circular grain bin pad or something like that, is an answer like 54 pi over 180 square feet gonna make any sense? No. We're gonna change our final answer to a decimal. Okay, not before that, but our final answer we're gonna convert to a decimal. If I'm gonna plug this into the calculator, I don't really have to reduce this. Okay, I'm gonna be multiplying this times other stuff. If I'm gonna put it in my if I was doing mental math with this, or if this was my final answer, I would absolutely reduce it to have smaller numbers. But if I'm just gonna put it in my calculator, I don't need to go through the work of reducing it.
Wait, is it okay if we
Well, I
do?
don't need to
Yeah, it's fine if you do. We just don't have to. So that's my theta in radians. So now, again, I always recommend starting with the formula. Or if you want to do r squared theta over 2, either way. And then just plug in the stuff that you need. So my radius is 6 squared. And I use parentheses pretty carefully. I'll put all of that in parentheses, so I treat the 54 pi divided by 180 as kind of one thing that it's going to get multiplied. And typically, I put parentheses around a number whenever I have an exponent. Have I talked to you guys about how your calculator will mess that up if you have a negative?
negatives because it'll keep it as -1 times.
Yes. Okay. So that's, even though I don't technically have to have it here, I pretty much will always put the number in parentheses if I have an exponent. That way I don't have to think about it.
Where are we rounding to?
Let's round to the nearest tenth.
17.
17.0. And then what would my units be? Because this radius was inches, so this would be
Inches squared.
inches squared. Okay.
And that's your sector.
All right. I could go through another problem like that, but for the sake of time, I think I'm gonna go on. For the next problem, we're going to find the radius. So this would be what, number 5? Okay. So it's going to give you the area of a sector. And our angle, in this case, is going to be 0.2 radians.
So, since it has the radians like
Since it's already in radians, we don't have to convert there. Now, what I'm going to tell you guys, though, start with your formula. Either one, I don't care which variation you put there. But since I'm trying to solve for r, typically it's easier to rearrange your formula before I plug numbers in. Because if I had fractions, or especially like if this was, instead of 0.2 radians, if it was like 3 pi over 4 radians, instead of putting that in and then having to do all the operations with 3 pi over 4, it's easier to just rearrange your formula once and be done. Okay? So if I'm trying to solve for r, what do I have to do?
multiply by r squared.
I've got to take care of this 2 first. Multiply both sides by 2. Divide by theta.
Wait,
So
don't you already have your area? You forgot to put your area in the equation.
It's right there.
No, like it gives us the answer, so wouldn't you put 15?
I'm rearranging the formula before I put everything in.
Wait, how come you still have to?
And I'll show you another reason why that's beneficial to do. So I'm gonna flip sides here because since I'm trying to get R, I like to have it on the left when I get done. So that's gonna be 2 times. And then square root both sides. Because I've got R squared, I've got to cancel out the exponent by square rooting.
So is the square root the whole fraction?
Yeah, the entire, because I have to square root both sides, that includes,
So it's the whole fraction.
yeah. Good question. Another reason this is beneficial, besides it's easier than if I had a messy number to try to plug in there and do all the operations with. So now I just plug everything in at the end and I can just type it straight into my calculator one time. I don't have to worry about rounding errors beforehand. And then also, say I had another problem right after this that was the same sort of setup. Do I have to go through all this process again? No, I've got,
Now that we have that answer, can we just use the?
yeah, you could, honestly, I don't care, on your homework, as long as you know how to do this on your homework, that's the thing with algebra. We don't have to reinvent the wheel every time just for changing the numbers. We've done the process once and now I can just plug stuff in. So if I plug numbers into that, so it's 2 times the area divided by theta, which is 0.2.
Yeah, I just took the first one.
30 divided by 0.2 would be 150.
It's 12.2.
Square root 12.2.
How did you just do that in your head?
Oh, it'd just be.
I didn't, I used the calculator.
Square root.
I'm not talking to you, I'm talking about Mr. Doll.
All right, we'll get the worksheet tomorrow.